Hello, my name is Daniel Estrada. This is the final lecture of my free will lecture series. Unlike the other lectures, I'm going to make this short and sweet and to the point. Try to get right to the heart of the issue. What we're going to be talking about today is the question, are machines free? And I'm not going to be answering this question in the general or in the abstract. I want to talk about a very specific case of machines and freedom. I want to talk about the Perseverance landing. The Perseverance rover, which landed on Mars a couple of weeks ago. And during a lot of the media around its landing, the NASA engineers who landed it emphasized Perseverance's autonomy in its landing operation. In contrast to earlier rovers, NASA sent a lot of these rovers, and the rovers have gotten increasingly sophisticated, and Perseverance was uniquely autonomous, especially during its landing procedure. And so I want to talk about Perseverance's landing procedure and to what extent it's autonomous. My goal here isn't really to convince you of any position. I really want to just break down the debate as I understand it and sort of motivations for the different positions in the debate. This is a little bit to set up some of the debates that we will have in class. But this probably won't cover everything. You might have ideas on these issues that differ from what I'm going to present here. But this is just really to start the debate and give it a little bit of structure. So there's a lot of details here. I have some videos in the slide deck to watch that gives you a lot more details about exactly what's going on with Perseverance's landing. But just a couple of facts to put on the table for the discussion. One is that there's a long signal delay between Earth and Mars. The signals can't travel faster than the speed of light. It takes about 11 minutes for light to go from Earth to Mars, depending on where they are in their orbits. And this is problematic for landing a rover on Mars because the landing operation from when the landing pod hits the Mars atmosphere to when the wheels are on the ground for the rover is about 7 minutes. And because that's shorter than the signal delay between Earth and Mars, that means that there can be no human intervention during the landing operation of one of these rovers. So even if something goes wrong, by the time the humans hear about it, it will be long over, and there'll be nothing you can do about it. So one reason this is nice for talking about autonomy is because we have at least this one hard constraint on human intervention. There can be no human intervention during those 7 minutes of landing. Now, this has been a problem for all of the rovers that NASA has sent to Mars, and so NASA's come up with a couple of different strategies for these rovers. Some of the earlier rovers, like Pathfinder and Spirit and Opportunity, had what we might call an uncontrolled landing procedure, where they couldn't really control in any sophisticated way where the rover was going to land. So what they did instead is they inflated a bunch of big air balloons around the rover, enough to allow it to bounce off the surface, and it'll bounce a couple of times, sort of like rolling a dice. And you don't know exactly where it's going to land, but the idea is that you land it in a place where there's enough open field that the big balloon airbag can roll around on the surface of the Mars for a little bit, bounce around, and then settle to a stop. So this sort of uncontrolled procedure was how Pathfinder, Spirit, and Opportunity were sent to Mars, how they landed on Mars. Curiosity was a little bit different. Curiosity was much bigger than the other rovers. Curiosity is about the size of an SUV. The NASA engineers decided that this was too big for it to safely land and protect all of its sensitive equipment with the same airbag procedure. So Curiosity was the first of these rovers to use this sky crane procedure. The sky crane procedure is the same general structure of procedure that Perseverance used, but there were some differences. And importantly for Curiosity, the landing procedure was all planned in advance. They landed Curiosity in a space where they were pretty sure where Curiosity would be for the landing, and they made sure that the space was sort of flat and open enough that even if they were a little bit wrong in the calculations of where Curiosity would be landing, they were able to execute the procedure. The important thing about Curiosity's procedure is that it was entirely controlled, that every step of the operation was sort of planned out in complete detail in advance by the engineers on Earth before they sent the rover up, so that when the rover executes the procedure, every step of that operation is planned out in advance. So, for instance, the sky crane operation happens at a certain altitude, and so there's some detectors and sensors in the rover that detect what its altitude is using radar and so on. But once the rover knows its altitude at a certain altitude, then it deploys the sky crane procedure, and so on. And all of that is planned out exactly in advance. At a certain altitude, do this, and so on. So this is the curiosity procedure, and perseverance is autonomous. Perseverance's autonomy is notable in the way that it contrasts with curiosity. So for curiosity, every step of this procedure was planned in advance. For perseverance, perseverance has autonomy in the sense that it decides to some extent where to land. So not every step of perseverance's procedure is planned out to the same detail as curiosity, and this gives perseverance some leeway in deciding where to, air quotes here, deciding where to land. What the engineers do is, so they have a general idea of the area that the robot's going to land, but they don't know exactly where it's going to be, and so they give perseverance a map of that terrain, and they mark some of the map as good places to land, and they mark other places on the map as bad places to land. And then as perseverance is landing, it figures out where it is with respect to this terrain, and then compares its trajectory to the map to decide, given where it's headed, where's the best place of landing. It's not going to know all these details in advance. It's going to depend a little bit on where perseverance is. And so perseverance uses its own sensors to help itself make the decision. This is again is a decision that the engineers on Earth did not know in advance, in contrast to Curiosity's case, where it wasn't that they knew exactly where Curiosity was going to land, but they had enough wiggle room that they could land it out in a big enough open space where even if they were off by a little bit of where to land, the procedure would still work. By making Perseverance a little bit more autonomous, they were also able to land Perseverance in a more rough terrain where there were more dangerous places to land where you shouldn't land, and because the humans wouldn't be able to correct for those dangers in the moment, they had to give Perseverance the capacity to make the decision about where to land as it was landing during those 7 minutes of no communication. So it's in this sense, in this sense of deciding where to land, that we're going to be talking about Perseverance's autonomy. This is the sense in which NASA engineers are describing it as autonomous. And the question for us, from more philosophical guys, is Perseverance actually making a decision? Is this decision free in any important sense? Is it responsible for its decision? To what extent is Perseverance autonomous in the more philosophical sense of the term? Okay, so again, I don't want to convince you of any particular solution. I have my own preferred solutions, which will probably be obvious as we talk. But my goal here is really just to lay out the different parts of the debate. So we're going to go ahead and start with some reasons for thinking that Perseverance is free, really just based on some of the facts that I just went through. And you might dispute a little bit how I'm presenting these facts, and we'll come to this. But just some considerations on that weigh in favor of Perseverance, of thinking about Perseverance as being free or autonomous in some important sense. So the big one, and the reason why we're using this example, is because Perseverance is causally isolated from the humans. There's this 7-minute or 11-minute signal delay, and that puts hard bounds on how much interaction the humans actually have with the machine. As it's going through this complex landing maneuver, right, lots of different things are going on in this procedure, but we know with some certainty that humans aren't intervening in that process. Except to the extent that they designed the machine. So they designed the machine, they set it all up, but then the machine's, as it's landing on Mars, it's sort of on its own. There's a strong causal separation where anything we do here is going to take 11 minutes before Perseverance is even aware of it. So we won't have time to intervene during the landing. So that's one point in consideration of thinking that Perseverance is free. Another that was mentioned in describing the case is the epistemic opacity, or what philosophers might call epistemic opacity, which is just to say that we don't know what the machine is going to do. Sort of its actions are opaque to us. Like there are things about what it will do that we don't know in advance. Perseverance's operators don't know ahead of time what the robot will do, and so that makes that gives some compelling reason to treat its operation or its actions as a decision or as autonomous in some sense. In what sense? Well, remember from our discussion of the free will debate, the libertarian position describes the motivation for its position in terms of this garden of forking paths, that it seems that to some extent that we're faced with choices, we're faced with this sort of forking paths ahead of us, and that we are able to choose among these paths, and that our choices are, in some important sense, up to us. That it's us who are making the choices. Our choices are not forced by some outside force, but that it's really us doing it. And again, the worry from libertarians is that if we believe in determinism, if we believe that the world is made of deterministic processes, then it seems like it's not really up to us, but it's up to these sort of grander laws of nature or whatever. So with perseverance, I want to say that one point in consideration of its autonomy is that it also seems like perseverance is faced with its own choices about where to land, that there are some garden of forking paths ahead of it where it has sort of some options of where to land and has to make a decision among these options. And which decision it makes is up to the robot in the important sense that it's not entirely up to the engineers, at least in the same way that curiosity was, where curiosity landed was to some extent entirely up to the engineers. But for perseverance, there's this sort of this gap between what the engineers planned in advance and what perseverance is able to do. This is not to say that perseverance has the same kind of autonomy or decision-making capacity as any human being, or even the same capacity as a child or as a squirrel. This is just to say that it's faced with some choices and that it has some autonomy in the way that it makes those choices. And in particular, that its autonomy is up to it in the way that seems to matter for the libertarians. In particular, that perseverance's decisions are based on what it's reading from its own sensors, right? So again, it's not just following commands from the engineers on Earth. It is making a decision in light of its evidence and the evidence that it gets from its own sensors. So this seems like a kind of self-determination that might matter for perseverance's autonomy. One last thing to mention is just that NASA engineers do recognize perseverance as an autonomous robot. They call it autonomous. They use this language. So there is some community recognition, and especially that community recognition is not just from any Joe Schmo on the street, but this is from the experts and engineers who built and design and operate perseverance. They seem to be the ones in the best position to appreciate the complexity and autonomy of the machine, and from that expert position, they use this terminology of autonomy, of treating the machine as an autonomous agent. Now, maybe there's also sort of PR motivations for this, that NASA is trying to appeal to a popular audience with a cool robot, and talking about it as autonomous is also cool and this sort of stuff. So maybe there's some conflicting motivations among the community, but it's at least worth noting that the engineers do describe it as autonomous. Okay. So these are just some considerations in favor of perseverance's autonomy, and just to help you sort of visualize how I'm thinking about this, I have these put into a chart. So here are the different robots that we talked about, the uncontrolled robots like Spirit and Opportunity, the controlled landing robots like Curiosity, and then the autonomous robots, or what the roboticists call autonomous, like Perseverance. All of these robots are on Mars, so they're all causally isolated in the same sense. There's the same sort of signal delay between us and the robot, so they're all causally isolated in the sense. They also seem like they're all epistemically opaque in the sense that we don't know what they're going to do. The uncontrolled robot is sort of rolling around almost at random, or the same sort of randomness that we see in a dice roll. So the uncontrolled robot seems epistemically opaque just because it's random. The autonomous robot is also epistemically opaque because we don't know what the robot's going to decide. You might quibble here about whether the controlled robot is epistemically opaque. My thought saying that yes is because we don't actually know that the procedure is going to work until we execute it. So we can plan it out in advance, but physics is wild, and it's a really hard engineering maneuver, and so we don't know for sure that it's going to work until we actually do it and see if we get the signal back. It's just as likely that we get a signal that the machine crashed and exploded. In fact, more than 50% of the missions to Mars have crashed and not worked. So it's very likely, because physics is hard, because engineering is hard, that the machine wouldn't do what we thought it was going to do. But so maybe you want to put a no here. I'm open to that. The really important issue with Perseverance's autonomy that's different from the previous robots is that Perseverance is executing a decision procedure that is self-determined in some important way, and maybe in virtue of these things gets community recognition. among these engineers as autonomous, and these same engineers don't recognize either the controlled or uncontrolled operations as autonomous in the same way that perseverance is autonomous. Just for the sake of it, it might be useful to compare these robots to human child and human adult. Maybe we're in the same sort of condition of epidemic opacity with respect to humans of all sorts, that we don't always know exactly what they're going to do. It's interesting here that humans are not causally isolated. It's very rare to get a completely causally isolated human. And this is maybe the most important contrast with the robots. Of all these different issues, that almost no human, child or adult, is completely causally isolated from the rest of the humans. Whereas part of the point of building these autonomous robots is to send them into places that it's very hard for humans to go. Send them into nuclear reactor cores, or sending them to Mars. Or sending them to the bottom of the ocean. Right? These are places that it's very difficult to get a human safely to those places. It's easier to get the robot to those places. So the reason why we build these robots is to go places where humans can't go, where they're going to be sort of extremely causally isolated from the rest of humanity. So that's a really important difference between what these robots are doing and what the humans are doing. But we can go through the other things too. I have question marks in these 4 squares because, to some extent, the issue of decision procedure and self-determination is at the core of the free will debate. And so I don't want to prejudge the free will debate. The point here is not to take my side in the free will debate either. So you might think that children don't execute a decision procedure, whereas humans do because whereas adults do because adults are rational. Maybe this distinction is not something that you think in the free will debate. Maybe also you think the child is not self-determined in a way that the sort of mature human adult is. But maybe you don't. So I don't want to prejudge these cases. In some ways, these 4 issues are at the core of the free will debate more generally. So what is maybe a little bit less controversial is the community recognition that our public institutions like schools and voting and drinking age and so on, that we do not recognize children as having the same kind of autonomy as adults. So there's a social, sort of institutional, traditional practice distinction between how we treat adults and how we treat children along the lines of autonomy. Maybe this is a similar kind of distinction between the robots, but maybe this is a lot more complex because humans are more complex. So I just wanted to sort of frame that, and maybe it helps see how I'm setting up the issue. Okay, so I want to go through 2 kinds of objections to the claim that perseverance is autonomous. 2 ways or reasons for sort of rejecting the view that perseverance is autonomous in any meaningful sense. And the first of these I'm going to call the design objection. The next is going to be the use objection. And what distinguishes these 2 kinds of objections is whether they're concerned with what happens before operation, like before the landing procedure. What did we do to the robot on Earth as we designed it before we sent it to Mars? And if you think our design of the machine is what really matters for assessing its autonomy, if you think the design limits its autonomy, then you might be motivated by these design objections. The use objections are about what happens during the actual procedure itself, during the operation itself. It's not as concerned with what happens before operation, but you might think that, designed or not, the machine during its operation is not sophisticated enough or complex enough to be considered autonomous. Okay, so I'm just breaking up these in sort of 2 categories of objection. Let's go to the design objection first. You might call this the Lovelace objection, because this is basically Lovelace's objection. Maybe this is a sort of a stronger version of Lovelace's objection. I'm not exactly sure that Lovelace would entirely buy into the strongest versions of this objection. But Lovelace says that the machine can't be autonomous if it's designed that design machines only do what we know how to order them to perform, or what we build them to perform, what we program them to perform. Right? For Lovelace, the fact that we programmed the machine, the fact that we had designed the machine to do some things, means that the machine does not genuinely get credit for doing those things. It's not genuinely autonomous in its operation because it's designed. The fact that we designed it makes it not autonomous. So if you think that perseverance can't be autonomous simply because it's a designed object, that's an artifact that engineers built to do those things, If that's the end of the story for you, then you're maybe motivated by the Lovelace response to Lovelace objection. A couple of things to note about this objection. One is part of the implication here is that the actual details, the mechanical details of some system don't really matter. Like, you could have some machine that works in a very sophisticated way. It can be, super cutting edge. As long as it's designed, as long as I know that someone built it to do those things, then I know that it's not autonomous. And it really doesn't matter what special new feature or what sort of widget is inside it. Its design is what sets some constraint on its autonomy. You might even put this in more explicitly Aristotelian terms, that design is something essential about a thing, and we can infer constraints and limitations on its operation, how autonomous it can be, from merely knowing the fact that it's designed. Right? So if we know it's designed, we know something essential about the thing that limits and constrains its operations. If it's designed, it can't be autonomous. So I think a lot of people are motivated by this. I think maybe to some extent Lovelace's objection is the strongest and most popular objection to artificial intelligence of any form, because to some extent Lovelace's objection is an easy objection. You don't really have to consider anything about the details of a machine's operation. You don't have to know anything else about it if you know that it's designed. Knowing the sort of origin story of the machine is enough to determine exactly how autonomous it can be. Okay, so if you're motivated by the design response, then you reject the claim that the machines are really causally isolated in the important sense. No, there is, in fact, the design objection person will say, no, there is, in fact, a causal relationship between humans and the machine, is that we designed it. That's the causal constraints that we impose on the machine, so that when it's operating up on Mars, it doesn't matter how far away it is, it doesn't matter that there's a signal delay, everything that it does is still a product of our intentional design. So it's not really causally isolated in any meaningful sense. It's also not really self-determined in any meaningful sense. All of its determinations are set up by the programmers and designers and engineers ahead of time, and this is what limits the machine from any kind of autonomy. And the point about community recognition, the Lovelace objection is just going to reject it out of hand. People can tell whatever story they want, whatever anthropomorphic story they want about robots. If NASA finds it good for PR to talk about the robot in terms of it being autonomous, that's fine. But that doesn't really show that the robot is autonomous in any meaningful sense. This is just a story that we're telling ourselves for, because it personalizes the robot and makes the story feel more interesting. Okay, this is the design objection. I'll give some responses to the design objection, but maybe first, and this is probably the most important part of this video, is just to distinguish the design objections from the use objections. So the use objections are about what actually happens during the landing itself. Design is not an issue, and there's less sort of implicit Aristotelian essentialism in this kind of objection. So this objection is more grounded on the kind of complexity required for autonomy. Remember, the design people don't care about the complexity. It doesn't matter how complex it is. What matters is that it's designed. But you might think design can yield things that are very simple, but design can also yield things that are very complex. And maybe you can design something that's complex enough to be autonomous. But someone who thinks that autonomy is a result of complexity might object to Perseverance's autonomy along several grounds, along several lines. For one thing, it's not alive, it's not organic, it's not self-organizing or self-replicating, it's not evolved through natural selection, it doesn't resemble anything like the kind of complexity that we see in biological processes. So just the fact that it's made of metal and that it's run by computers and so on makes it so different from the other kinds of things that we consider autonomous, namely living creatures, that seems to be a mark against Perseverance's autonomy. And again, this is not a claim that it's not autonomous because it's designed. This is a claim that it's not autonomous because it's not organically complex enough. The dynamical patterns of self-organization are not at the level of complexity required to be autonomous. If being alive is not the thing that motivates you, you might also be interested in something like rational self-interest, or being driven by sort of intrinsic desires or emotions or some internal feeling. Maybe you think consciousness or self-awareness or some sort of qualitative experience is the more important thing for something to be autonomous. But we might think of all of these kinds of objections as ways of stating the more general claim that the system is just not complex enough. Right? It's not making rational decisions. It's not self-interested. Perseverance doesn't really care about anything. Right? It's not motivated by anything. It doesn't feel any hunger. This kind of stuff. Or maybe just that it's not conscious at all. That it doesn't have any really self-aware experiences. In a kind of Lockean vein, we might make the argument that perseverance can't do otherwise. I think this has come up in class several times. This is a sort of very popular response that perseverance can't decide to go to Venus if it wants. Or can't decide to not go to Mars and just stay in its room and play video games. Right? These are not the kinds of decisions that perseverance can have, so it can't do otherwise. Right? If its desires were different, it wouldn't act different. And this seems historically, people have said this is an important dimension of freedom, and it doesn't look like this is the sort of freedom that perseverance has. So these are all reasons for thinking that perseverance isn't autonomous in its operation. And again, really important that these are not claims about its design. You might think that we can design something that's organic and self-organizing and self-replicating that would be autonomous, but that's just not what perseverance is. Or you might even think that we can design something that's self-aware and conscious. Maybe not. So use objections are compatible with design objections, but the point I want to make is that they're not the same objection. That you can endorse the use objections without endorsing the design objections, and vice versa. They're independent. And this is why it's important to distinguish between before and after, or before and during operation. One challenge for the use objections is that it seems to put it puts the argumentative burden on the use objection to state what that threshold is, what counts as complex enough, and why. Why does that matter for operation, for the operation of the machine? Another way of looking at this is when someone says, well, this is what you need to have in order to be autonomous. Eventually we have engineers that build some machine that does that thing. So part of what we're doing when we're stating these use objections is we're setting some benchmark or goal. Maybe perseverance isn't an autonomous machine, but maybe if we had perseverance made out of some organic material so that it was self-replicating and could sustain itself on Martian surface, maybe that would be considered a really autonomous creature, and that's a different threshold than what perseverance has accomplished. Okay, so two different kinds of objections, the design objections and use objections. I want to give just a couple of responses. I'm almost done here. I want to give just a couple of responses to both of these kinds of objections. So again, I just want to make a note that the design objection has a burden of explaining why and when and how design makes a difference. And in particular, does design have some mechanical force associated with it? In what way or how is design, if design is something that happened before operation, how is that thing having an influence on the operation itself? Like you might think the design goes into deciding which gears and which programs to write and so on, but once it has those programs, then everything else is just a mechanical unfolding of those operations. The cogs and the computer and the programs and the machine, all churning along, doing what they were set up to do by the programmers. But you might also think that design has some more metaphysical basis, that there's like a design force, similar to how Aristotle talks about final cause. That there's some sort of purpose or structure or essence to the thing that makes it this kind of thing and not some other kind of thing. You might think that the reason that designed objects can't be autonomous is because that's what it is to be a designed object. That's sort of the essence of a designed object. And once we've designed an object, it can't escape that essence any more than a skunk can become a cat through changing some feature of its behavior or some external property. There's nothing you can do to change the essence of a thing, and if a machine is always designed, then and no designed thing can be autonomous, then there's nothing you can do to the machine to make it any less designed or any more autonomous. But there are worries here. So to some extent, we do consider some organisms to be autonomous even when they're designed. So we're thinking of things like domesticated animals or even plants. They're alive. So domesticated wheat, for instance, we've changed wheat over thousands of years to be very productive and so on, suit human agricultural purposes. So these are designed, domesticated creatures, but they're still alive and they're still autonomous in the sense that they grow on their own. Wheat still grows through energy from the sun and this kind of stuff. We haven't interfered with that autonomous living organism except just by modifying its features over thousands of years to suit our agricultural interests, to make the wheat productive and so on. So these things are designed, maybe even humans are to some extent designed. The example here is like the semester schedule. So everyone in a college system, both students and faculty, sort of arrange their schedule, arrange their lives, at least for a few weeks, around the semester schedule for the school. This means that basically when I'm waking up and going to sleep is to some extent determined by university administration, and I don't have entire control over that. And as a result, a lot of features of my life are designed, imposed by outside forces. This is something that all autonomous organisms are going to go through to some extent. We all have to live in a world populated by other autonomous organisms that are doing things that we might not always like. But while the administration setting the semester schedule does constrain my behavior to a certain extent, we don't typically think that it rips me of autonomy or that it takes the autonomy from me. It really just constrains my behaviors in certain ways. So I can't party late on Tuesdays because I have classes on Wednesdays or whatever. That doesn't mean I can't party ever. It means that I can't party within these constraints that are imposed by this institution that I'm a part of. So if autonomous organisms can still be constrained and even designed in certain ways, then why should we count the machine's design against it? Why can't we consider it autonomous also in sort of similar ways to the ways that we're autonomous, even while we're designed? I guess finally on this slide, there's a worry about, from the design objections, if the design objection is pointing at something essential about a system, about a machine, that it's designed by its very nature, and so it cannot be autonomous. Why can't machines change that about themselves, or what would a machine have to do to break this sort of essential, essentialist notion? And the point I want to make here is that as soon as you start talking about what the machine has to do in order to be considered autonomous, then we're out of the realm of design objections and we've moved into the realm of use objections. If we're talking about what the machine must do, even if it's something as abstract and sort of vaguely specified as like break its programming, well, breaking its programming is some operation that it has to perform in the moment of use. And if that's enough to do it, then design maybe is not the decisive end that we might think it is. So moving on from the design objections to the use objections. So imagine here we're not hearing so much that it's designed, but that it's just not complex enough. So people who raise use objections have, I mentioned this earlier, have some burden, sort of argumentative burden in this discussion to identify what the threshold of complexity is and what would be required to cross it. So if you think it has to break its programming, well, so what does that actually mean? Doesn't every computer, when it's executing a program, change those programs in some ways by changing variables and changing sort of state parameters and so on? Computers code themselves. Computers can write their own code. This is what compiling a program is. So these sorts of things aren't. They're not terribly surprising. Computers have been doing them for a long time, but why is this not enough to meet some of these use objections? We might respond to people who raise use objections that the machine isn't complex enough. We might just ask, why does it need to be that complex? Humans need to have the kind of complexity we do because of the evolutionary niche that we evolved into, but perseverance isn't operating in a niche as complex as ours. From the perspective of a living organism, Mars is very barren and plain and simple, and that's what makes it perfect for the robot to interact with, because the robot doesn't have to be so complex. It doesn't have to be self-organizing or self-motivated. It doesn't have to be conscious in order to do all the things that it needs to do during its operational lifespan, or it has a mission to execute. It's not coming back to Earth when it's done, so there's only a certain number of things it can do before it wears out. And doing those things doesn't require all this other baggage that maybe living organisms like us carry around, like that we're self-organizing and self-replicating and so on. It's easier for Perseverance to be on Mars because it doesn't have to eat like we do. That's one reason why Perseverance is designed the way it is. To say that it, in order to be autonomous, it needs to replicate all these things seems not driven by anything in particular, except sort of familiarity with other things we consider autonomous. I mean, but why are those things necessary? Especially for the landing procedure, Perseverance does not need to be self-organizing in a biological sense in order to make a decision about where to land. These things seem very loosely related, if they're related at all. Another thing to say in response to use objections is that so I'm not making the argument that Perseverance has autonomy like a human is any way at all as sophisticated as a human. Perseverance is making very narrow decisions within a very limited domain. So humans definitely have more control over our operations, but our operations are controlled in the same limited way. So the example I'm thinking about is, if I'm trying to go somewhere and I know someone who's been there before, and I ask them to show me on the map how the best way to get there, and they show me on the map, and then I follow their instructions. Me following someone else's instructions, following someone else's map, it seems to me that we usually don't take this as a hard constraint on my autonomy. The fact that I'm following someone else's map about the best way to get somewhere is not a constraint on my autonomy, really. And if all that Perseverance is doing is following a map that someone gave it, recommending the best location, then why is that considered a constraint on the robot's autonomy? So maybe we can go back to some of the earlier sorts of issues raised, like Perseverance couldn't have done otherwise. So Perseverance could not have decided to land in a place where the NASA engineer says was a bad place to land. Like its programming sort of prevents it from making that kind of decision. Whereas I could have decided that the instructions that my friend gave me are not good instructions, and to reject them or go some other path. So it seems like maybe I have opportunities to do otherwise where the machine does not. But again, even for human autonomy, our decisions are still limited and framed and constrained in all sorts of ways. The burden here is on the use objections to explain why the control over the parameters in the robot is not sufficient for meeting what's necessary for autonomy. Again, this is just going through objections, sort of structuring the debate where the strengths and weaknesses of these different challenges are, sort of what is at stake from these different perspectives. I hope that's a little bit helpful. I just want to say one more thing to sort of end this out, though, which is to talk about the community recognition issue. So we might be unsatisfied with both the use and the design objections, and maybe here's a way of giving an alternative perspective that puts the emphasis elsewhere, puts the emphasis somewhere other than just these issues of self-determination, which is to put the emphasis on community recognition. So I'm calling this a social relational alternative. This is a view that's defended by people like David Gunkel and Mark Kokelberg, who you can find in the reading list. But the claim here is that to call something autonomous depends to some extent on what it can do, what its capacities are, but it depends maybe much more deeply on social attitudes, on social practices, tradition, conventions, on institutions that we have set up, on belief systems and ideologies that people have, that these ideologies, these belief systems, these social attitudes are the driving force in informing how and when we treat certain people as autonomous. The easy example here is something like the drinking age or the voting age. So the drinking age is 21. The world would probably not be such a different place if we made the drinking age 20 or 22. It would make it slightly less convenient or more convenient, depending on if we shift it 1 year up or down. it would make it slightly more or less convenient for certain age groups for a very limited amount of time for a single year. But otherwise, things would be mostly the same. I don't think people really believe that 21-year-olds are so much more autonomous and mature and in self-control than 20-year-olds. I don't think anyone really believes that moving from 20 to 21 endows people with some extremely enhanced self-control and autonomy. I think instead people basically understand that setting the age limit for drinking at 21 is really out of social convenience. That some people at 21 are not mature enough to drink. Some people might have been mature enough to drink much earlier than that, but the laws prevent them from drinking. But most people understand that. But yeah, you have to make a law somewhere, so they set the law at 21. We could have decided to make that law different, and this is just a change in attitude and convention. This is not really a change in who really is and who really isn't autonomous, right? So we understand that for some things like the drinking age, we make distinctions based really just on tradition, on these certain kinds of social practices and conventions. And maybe that's really the important thing that's going on here, that there's some people with social attitudes going one way and some people with social attitudes going another way, and there's not really a deep answer underneath it all, just like there's not a deep answer of when is the right age for everyone to start drinking. That's going to depend quite a lot on from person to person, from situation to situation. Nevertheless, we have these social practices, and we have these laws that draw sort of more or less arbitrary lines in the sand, and we all basically work around those lines because that's what we have to do. So maybe that's also what's going on with perseverance. Maybe the debate over perseverance's autonomy is not really a debate over the one and true vision of what perseverance really is deep down inside, but instead maybe this is just a conflict between two different normative communities, two different value communities. One community which values or finds some social value in recognizing the robot's autonomy, and another community which finds social value in rejecting the robot's autonomy and instead emphasizing the distinctions between robots and machines, between humans and machines. Right. So the engineers at NASA have maybe lots of incentive for recognizing the robot's autonomy. Maybe some of this incentive is technical, like it helps them understand and plan for and design the machine in order to do really amazing things. Maybe it also has, as I mentioned before, it has PR value for the media. It gets people talking about these robots if we call them autonomous. But maybe that's just in conflict with other people who are sort of really protective of what it means to be human and how humans are special and how humans and robots are distinct. And what we really have here is just two value communities sort of responding to each other by emphasizing different aspects of these machines. So if you're a social relationalist like this, maybe you don't have anything concrete to say about whether perseverance is autonomous or not. Like it depends on who's asking. It depends on why we're asking, and maybe that's unsatisfying for various reasons. Especially if the dominant view is one that rejects the machine as autonomous or is sort of really hostile to the suggestion that machines are autonomous. So if you want to think that machines are autonomous and you sort of hold something like the social relational view, there's good news. And the good news is that social attitudes can change. If people don't think robots are autonomous today, maybe we wait a few generations and your kids will have a much easier time thinking that robots are autonomous because attitudes change and conventions change. And maybe if we've lived around robots for long enough period of time, and not just talking about days or years, we're talking about generations, and enough time to build alternative institutions and social practices. And maybe if we have new social practices, then we will consider robots autonomous. And maybe what's going on right now is just that we're not at a stage where we're ready to adopt those practices. So social practices can change. We've seen in our lifetime social practices change on a variety of issues, some of which might be very socially and politically controversial. But social practices can change. The bad news is, though, that social practices don't change as a result of sort of reasoned, careful debate. It's not by going carefully over the various theoretical and ideological commitments of the different sort of positions in this debate. This is not really ends up convincing people one way or the other. Instead, people change social attitudes over time through activism and through time by waiting, not by waiting around, but by letting time pass. Sometimes by letting generations pass. debate is not enough. We're going to have a debate over these issues in our classes, but debate is not enough to settle these issues. Debate is really just enough to express and consider these issues. So the point of the debate, just like the point of this video, is not to settle your mind one way or the other, but it's just to help you think and give you some tools for thinking through some of the nuances of this debate. I hope you found this helpful. I hope you are ready to do some of these debates in class. Thank you very much for listening, and be good to each other.